Assalamualaikum warahmatullahi wabarakatuh. I am Shazam bin Ismail. My number metric 11 DKA 18F 2016. I want to present to you Fluid Mechanical DCC 5143, Chapter 9, Understand the Energy Loss in Pipe neck. For the introduction, it is often necessary to determine the head loss, which occurs in pipe flow to energy equations can be used in flow problem analysis. The overhead loss of the piping system consists of a head loss due to the condensing effect on the straight pipe, which is called a large loss and is denoted by if main. Head loss on the various pipe component is called small loss and is denoted by HL minor. Total head loss H. The answer HF major plus HL minor. Determine the loss of the major and minor. Head does not necessarily reflect the relative importance of each type of the loss. For piping system that contain many components and relative to short pipe lengths, small loss may actually be greater than major loss. That we have the energy loss to the major energy loss and minor energy. In major energy loss, have the two part for the major energy loss. Number one, formula Dressy Washback and formula Chases. For the minor energy, have the five item in the minor energy: student enrichment, student shrinkage, missing out, incoming loss pipe bend. Formula Darcy Washback. The Darcy Washback formula was developed for use in the analysis of pressure pipe system. However, the formula is sufficiently general so that it can be applied to open channel flow system. In fact, the ASCE Task Force in Friction Factor in Open Channel 1963 support the use for the Darcy Washback from the formula for the free surface flow. For the formula, HF equal 4 times F times L times V square root 2 divide 2GT, or HF equal F times L times Q square root 2 divide 3D square 2. HF is loss of the head due to friction. F, so efficient friction. L, pipe length. V, velocity. D, diameter. And G, gravity. The cheesy formula to calculate head loss due to friction or measure loss. In number 1, head loss due to friction. For the formula, HF equal I multiply L for the M, and for the I, loss of the head per meter length, L, length of the pipe. Velocity of flow, V equal C radical Mi for the M divide S, and where C for the cheesy constants, M for hydraulic mean depth, A divide P, and P divide 4 is D. For the student enlargement in the diameter of pipe result in the formation of the eddies in the flow at the corners of the enlarged pipe. First, in the result in the loss of the head cross the fitting, loss of the head due to the student contraction. This is the energy loss of the dual student contraction. Okay, for student contraction. Student contraction in the area diameter of the float jet after in emerges from the circular Aperture in the pressurized reservoir is called as the vena construction. Coefficient in construction is the ratio of the across section area of the jet at the vena contractor to the area the coefficient. The exit loss h is the function of the change in velocity at the outlet of the pipe as shown in equation A. V equal average outlet velocity FPS or m divide S. For VD equal change velocity downstream of the outlet FPS or m divide S. CO is exit loss coefficient 0.5 second. For the interest loss, coefficient Ke is the head loss term of the energy equation for the open channel flow. The head loss coefficient is the measure of the efficiency of the inlet for smoothly transition flow from the upstream channel into the culvert, although it is the typical report as the constraint it does very wide flow. Pipe bend. Pipe bending is the technique used to various metal forming process with the aim increasing the fabrication capabilities of the plumbing mixtures. The pipe can be bent of the varying angle and different direction. The simple curve turn in the tube at the angle 90 degrees, forming the elbow. For the solution, D1 and D2 7.5 cm, 15 cm convert to 0.075 and 0.15 meter, and Q 0.0141 meter square s per second. For the V, to get V1 and V2, we got the formula Q per A. For V1, 0.0141 per 4.418 multiply 10 minus 3, and we can get 3.191 meter per second. For the V2, the same in number 1, 0.0141 per 0.177 equal 0.783 meter per second. We can get the answer. Thank you for the watching my presentation. Thank you.